proposition. If the limit of a sequence exists, it's unique. Okay, this is a very simple proof. Suppose we have two particular limits. Suppose that this was not true. Okay, so we're going to prove by contradiction. Okay, suppose we have a number a. It's called the limit when n goes to infinity of a sub n, and then a number b, limit when n goes to infinity of a sub n. So okay, two different limits, and let's suppose a is smaller than b. Okay, this is not important, but just suppose. Okay. Now, according to the definition of the limit, then we have a sub n minus a is smaller than epsilon for some n greater than capital N sub 1, and then a sub n minus b is smaller than epsilon for some n greater than n sub 2. Okay, so then we have the difference between a minus b. Okay, is just suppose we have n greater than the maximum of n sub 1 and n sub 2. Okay, so both conditions apply. Now, if we compute the difference between these two numbers, then we can apply this trick, subtract and sum the same number. Okay, this is the same because we're summing and subtracting the same number, and applying the definition of one of the properties of the absolute value. This is just smaller than this plus this, right? This is the triangular inequality. But we know that this is smaller than epsilon because we're taking a very large index that's greater than this 2. So this is smaller than epsilon and smaller than epsilon. So this is smaller than 2 epsilon. Okay. So the difference between the two limits is as small as we want it to be. Okay, we can choose very small numbers, epsilon, and so that we can make this smaller. So in other words, that the limit when n goes to infinity of a minus b is 0, which implies that a equals b. Okay, so we have proven that a equals b. So it doesn't matter this original assumption, it's not valid. Okay, so it can't be true. Okay, the limit is always the same. Okay, now proposition: every subsequence of a convergent sequence has the same limit as the sequence. Okay, this is kind of obvious. Okay, because a subsequence is a sequence that is contained in the original sequence, so you cannot go to a different limit than the original one, right? So I hope this is clear for you guys. So if you compute the limit to a general sequence, any subsequence that you can find will always have the same limit. Okay.